So we in Group 6 decided to explore the transportation paper called Investigation of Ready-Mix Concrete using linear programming. We chose to replicate the results of this paper because the data was already provided directly in the paper itself, and the steps are very clear on how to do so. The goal of this paper was to determine the quantity to be transported from each batching plant to meet a minimum cost. The channel design paper describes a linear program taking into account the various cost factors such as roughness, channel dimensions, bed slope, and design flow. The goal of increasing design reliability is in opposition to the goal of decreasing predicted costs through this model, and the formula that was mainly used was the formula in the bottom right. The irrigation scheduling paper describes the duration of flow in each outlet to schedule how much each canal gets, pretty much volume of water for each group of users. And the single period model minimizes the sum over all outlets of the differences between the requested target start times and the scheduled start times of flow to each user under this restriction, which is the top equation. And the second model, a multi-period model, gives customers who have previously experienced disadvantages when scheduling their actual start time with their desired start time for the upcoming period, which is the bottom model.
Material recovery facilities, diverting parts of the municipal solid waste stream from landfill disposal through recycling or other methods has received attention considering recent increases in the expense and difficulties of landfilling. Microsoft Excel spreadsheet software and a commercial linear programming tool are used to implement the proposed strategy. Shadow prices for a particular linear constraint determines the change in the objective function's best value that results from a unit change in the constant in that constraint. Knowing the change in cost that would result from modest increase in waste generation is important for waste components and specific source separation schemes. Pipe network. In this study, the advantages and drawbacks of developing linear programming models for water distribution network, leak detection, and localization while taking demand sequences into account were studied. Here, LP and BILP models were created to take a number of demands into account over time. The formulation of LP models for WDN pipe leak, localization, and detection starts with an unconstrained LP model. The best BILP model that constrains leak locations spatially outperformed the unconstrained model in detecting and locating relatively small leaks. Resource scheduling. Scheduling is the process of choosing the timing of the project's operations and assembling them to determine the total completion time. The method that has been devised is known as line of balance, and it is used for projects that include repeating networks, like a high-rise structure. The linear scheduling model was used to determine the controlling activity path. The ideas of rate float and activity float are used in the resource leveling formulation for integer linear programming that is discussed in this work.
Hey guys, this is MD Saffiquzzaman Chowdhury. So I'm from Group 6. So right now I'm going to talk about the methodology of the main problem from our paper was to determine the quantity to the transport from each source to the demand point with the lowest transportation cost. So to achieve this goal, we have imposed some procedures, and those procedures are at first we designed the problem as a transportation problem. After that, we determine the constraints and the decision variables. After the determination of the constraints and the decision variables, we build a mathematical model which is absolutely appropriate with our transportation problem. After that, we analyze the model with Excel solver. After that, we reproduce the same result from the paper by using RStudio code. After that, we compare the result of which we got from the RStudio code and the Excel solver with the paper which was given through our professors, and the final result was same in every sections. So from our paper, we have been provided some data. to reproduce the result. And we can see there are 7 suburbans and 4 batch plants, and the distance has been given from the each batch plants to the each suburbans. And we also can see there's the capacity which each batch plant can produce per year, and the unit is meter cube thousand for the concrete. And we also can see the demands of each suburbans has been given. So for our paper, our paper has a systematic approach which breaks down the model into the 4 parts. There is input parameters, decision variables, constraint, and the system out. And for the decision variables, Xij refers the amount of concrete transported from supply point I to demand point J. And we assume that the I represents the concrete batch plants, which is in number in 4, and J represents the suburbans, which is in number in 7. So for the constraints, the production quantity of the concrete batch plant is indicated by SI, and DJ denotes the demand of district. So for the concrete which has been transported through batch plants to the suburban has been denoted as Xij, should be less or equal to supply from the batch plants, and the amount of concrete which has been supplied through the batch plants to the suburbans should be greater or equal to the demand point of the suburbans. So for the challenge part and result and discussion part will be discussed by John, who is my another project mate. Thank you.
Hello, good evening. My name is John Daniel Deseyi, and today I'll be talking about the objective of paper 6 for group 6. Paper 6, which was the transportation of ready mixed concrete. Basically, the objective for this paper was to find out the cheapest way of transporting concrete from the batching plants to the sites where they are being needed. So after we applied the LP solver and we minimized the distance, we were able to come up with a cost of 16,925, which is 16 million, no, yeah, 16,925, which is what the we got from, which is also what they got in the paper. So we were able to replicate the exact same result. We did this using Excel solver, and we also replicated the same result using um, LP solver in R. Before I show you the exact results that we got, I would like to discuss some of the challenges that we faced while we were working on this project. One of our biggest challenges was our time constraint, because all of our group members had different activities, and it was really kind of difficult to get everybody together and work at the same time. So the time constraint was one of our biggest challenges. Another challenge was to understand exactly what the paper was asking us to do. We had excess concrete from the source, and the demand had concrete less than 5. So it was kind of challenging to figure out what we were supposed to do with the extra 500 cubic meters of concrete, of which we eventually did find that out. Reproducing the result, we also had a little bit of challenges in reproducing the result on R to find the right code to read the data and do the output solver. Um, the project consumed a lot of time, and the complexity of the model, because of the nature of the constraint. There were constraints from the supplier, and there were also constraints from the demand, so we had to merge these two together, and it was kind of tricky merging them, but eventually we did merge them. And so the this is the results that we got when we used Excel solver. As you can see from source one, this is what we had, and we were able to meet all the constraints that were required, both from the suppliers and from the demand. We were able to meet all the constraints. And the extra concrete, we had to put the extra concrete in the dummy site, which we just leave at site 8. And we were able to reproduce the exact same thing on R. So also we had to also introduce a dummy site where we put the extra concrete went to. The distance for that dummy site was 0, so it doesn't affect the total value of the total cost of concrete transportation. So thank you very much, and this is where we will conclude our project.